Section 4.3 is split into 2 days, so today we're going to look at the triangle inequality conjecture. We'll start with a warm-up. Find the measure of OLE. So OLE, let's find that angle and I'll mark it. So you start at the vertex O. So O to L to E is this angle right here. Okay, start with what you know. We have an isosceles triangle. The vertex angle is 35. The two base angles should be congruent. So to figure out these two angles right here, we're going to take 180 minus 35 and divide by 2. All right, so if you do that, each of these is 72.5. Okay, now we're going to use the linear pair conjecture. We have a linear pair, a straight line. We know that in a straight line, the two angles add to 180. So we're going to take 180 minus 72.5, and we're going to get 107.5. And that'll be in degrees. Okay, so that uses a couple different properties. Properties of the base angles in an isosceles triangle, and in a straight line, the two angles add to 180. In class, we're going to do the triangle sum inequality. We're going to explore the relationship between side lengths of triangles and identify what side lengths can actually form a triangle, because some don't work. And we're going to describe relationships between side lengths and angles of a triangle. All right, so in class we do a spaghetti noodle activity where we look at lengths that can form a triangle and lengths that cannot form a triangle. So it looks something like this. You have different lengths here. So let's say this is like 3 centimeter, 5 centimeter, and 12 centimeter. Can you put those together? Can they form a triangle? And so on. So we'll do that in class. We're going to find sides that work and sides that don't work. So for example, let's say we had side 1, side 2, side 3, and does it work? All right, so for example, if we had one side 3 and side 4 and side 5, this works. I should add another column too. Sum, I'm going to erase this. Sum of two smaller sides. Does it work? Okay, so the sum of the two smaller sides are 3 and 4, 7, and this works. Let's pick some more numbers. Let's say we had 3 and 7 and 11. All right, 3 and 7 add up to 10. The last side's 11, and this actually, if you try it, does not work. Let's do 1, 2, and 5. These add to 3, the two smaller sides. This does not work. Let's do 7, 8, and 10. 7 and 8 add up to 15. This one actually forms a triangle. So if you look for a pattern, let's do one more. Let's do 9, 10, and 11. And this will work. Okay, so take a look at all the ones that work and all the ones that don't. And what happens is, there's a rule here, the triangle inequality conjecture. Again, we do it with spaghetti noodles in class. The sum of the lengths of any two sides of a triangle has to be bigger than the length of the third side. And here's the reason why. Let's say they were the same. Let's say we had two spaghetti noodles and they were both length 8. And let's say this one was broken into a piece that was 2 and a piece that was 6. If you broke this right here and then tried to make it into a triangle, so one side's 8, and the 2 and the 6, you're going to break it and then try to bend it. It's not gonna, there's going to be a gap here because it was the same size, but then you're moving it up. So there's a gap here. This is 2 and 6. So these two, the two smaller sides, they have to add up to bigger than the biggest side so that they connect. Okay, so here they have to be bigger than the length of the third side. So the two smaller sides have to be bigger than the length of the third side. Okay, so it says determine if they would work. Well, is 3 and 5, is that bigger than 12? No. And if you try to stretch it out, see, it wouldn't work. So this would not work. Are 3 and 5 bigger than 6? Yes, it would, and so it would end up meeting if you try to drag it. I wonder if I can drag these. Oh yeah, you can drag them. Let me try it. Alright, so let's drag this. Oh, that makes it bigger and smaller. Well, maybe I can't drag them. Oh, I can drag the whole thing, I guess. But yeah, so you can see anyways, if the two smaller sides, they have to be bigger than the biggest side, so this will not work, this will work, this will not work. Okay. And let's see. One more conjecture, it's another investigation. Where are the largest and smallest angles? So in class, we're going to draw a triangle, we're going to measure the angles and the sides, and we're going to make a conjecture about different sides. Now, which side is opposite angle L? Here's the side that's opposite angle L. Here's the side that's opposite angle S. And here's the side that's opposite angle M. And we're going to discuss the results, but basically here's what it leads up to, the side angle inequality conjecture. In a triangle, if one side is longer than the other side, then the angle opposite the longer side is going to be bigger. Let's take a look at our picture here. MS is the longest side, and as you can see, this is the biggest angle. So here's the longest side. Here's the biggest angle. And it makes sense because the angle has to stretch out so that I can make the longest side. Okay, so the bigger the side, the bigger the angle. So let's practice. Measure the orders, or conjecture the order of the unknown measures in order from the greatest to the least. Okay, so let's figure out this angle first. So you know all our angle measures. We're going to do 180 minus 68 minus 55. All right, so this is 57 degrees. All right, so you look for the biggest angle, look for the side across from that. So 68 is the biggest angle. So C is the biggest side. The next biggest angle is 57, it's across from B. And the next biggest angle is across from the 55, which is A. So these sides are biggest to smallest, CBA. The next one, look for your biggest side. So there's your biggest angle. The next biggest side is 17, and that's across from angle C. And the next one's across from the 15, so that's angle B. All right, so two important conjectures. The first one is that the sum of the lengths of any two sides of a triangle has to be bigger than the length of the third side. And the other conjecture is that in a triangle, the biggest side is across from the biggest angle. And then it works its way down. Okay, so your assignment then is on your calendar. You can check that. It's actually, I think, in your packet as well. And then tomorrow we'll do 4-3 day 2.